is that I'm going to need this information that I had here. I'm going to need them again. So let me grab this information. And the nice thing about this is that actually I'm going to take this one at a time. So I'm going to first deal with the top part. And then I'm going to deal with the second part. So I'm going to think of this as the math market. Math tuition market. And really the only thing that I have is 2 data points. That's the only thing that I've been given. And what am I being asked for? For the optimal price and quantity. As simple as that. So my steps are going to be are going to be 1, find the demand equation, and after I find the demand equation is I maximize profits, right? Maximize profits. Okay, let's do that. Okay, let's find first the slope. So P is equal to A minus B times QM. Okay, what is B? B is going to be delta Q over delta P. I'm just going to take the absolute value of those stuff, okay? Absolute value of those stuff. So what was the change in Q? 5. What was the change in P? 5. What's the slope? 1. So I figured out that B is equal to 1. So this is step 1, okay? I'm just doing step 1 here. Then I can plug it into 1. So 30 is equal to A minus 30. Is that right? Changing Q. Yeah, changing P or changing Q. Changing P. Yeah, changing. Yes, sure. This would be changing P and changing Q. Yes. Okay. So the slope is 1. Okay, and one of the prices that I have is 35 and 30. And the other one that I have is 25 and 35. So in this case, A would be equal to 0. That doesn't make sense. 60. What am I missing? Oh yeah, 60. Whew. Yes, of course. My brain freezes sometimes. A is 60, right? So then you have the demand. You're kind of done with the first step, which is P is equal to 60 minus Q, M. You know the demand function, plus you know that marginal cost is equal to 13. You can use 3 methods to find the optimal price and quantity, okay? All these 3 methods originate from your desire to profit maximize. So let's start with just profit maximization. So let's, of course.
Could we also use the new price and quantity in that, or is it just in this case that it works out? Or can you always also use the 35?
Oh yeah, you could have, and it should have worked, right? So let's try that, just to convince ourselves. Price of 35 is equal to A minus quantity of 25. Bring the 25 on the other side, you'd find A is equal to 60. Yeah. It didn't matter which of the points you use because it should work for all points, okay? Yeah, Dorothy.
So when you calculated P, you said that it has to be an absolute value, what is that?
It didn't have to be an absolute value, okay? I could have taken this out and I could have said B shouldn't be an absolute value, and then I would say what happened to the price? Price went up by 5. What happened to the quantity? Quantity went down by 5, so I'll put a minus here and I'll put a minus here, okay? If I wanted to do it that way, it would be fine, but then I would change this general thing to just being A plus B. And then I would have put the B as being a negative number. In other words, I know that demand functions will have negative slopes. I know it. Because I know that demand functions will have negative slopes, I'm just going to do a negative here. And then that part that's remaining b should be only in positives. So I don't have to worry about is it increasing, is it decreasing. I just look at the change, right? And I take the positive side of that change, right? So then I do just 5 over 5 is equal to 1. Okay, that's easier.
So we never deal with that weird type of good.
Say again? Yeah, we never do it with a good that will be upward slope.
What's the name of that good again?
Given goods.
That's the one. Given
Yeah. Given goods would be goods that would have a positive slope, but we're not going to deal with those goods. Okay. Right. So once you're here, you can write down the profit function as a function of quantity and price. Well, that's easy. Q times P minus Q times MC. But let's do it only profits as a function of Q only. Well, that would be Q times 60 minus Q times 13. And then we can take the derivative of Q with respect to Q. We will get 60 minus 2Q minus 13 is equal to 0. This is my optimal quantity. So 2Q is equal to 47. Q star is equal to 23.5. Right? If I plug this into the demand function, P star will equal to 60 minus 23.5. Then what would be that? Would be 36.5 is the optimal price. Right?
Shouldn't you really compare it to like 23 and 24 Q? You can't really have half a lesson.
Right. Well, can you have half a lesson? Of course you can. You could have an hour and a half, right? This is a lesson and a half if you compare it to the standard thing, right? So if you're charging on a per hour basis, you can. Okay. So and that certainly does happen, right? You can charge on a per hour basis. You know, Jonathan, you've charged clients before on a per hour basis, right? They don't always take half. They don't always take the full, right? You can charge them.
Do a half day?
Say it again, half day, absolutely. So don't complicate your life, Angus, if you see something like this, with discrete numbers, okay? Just make it simple. Just do it continuous, and you'll be done with it. Because the moment you think of it as like hours, and the hours is divisible, then your life will be a lot simpler, okay? And that's it, right? How could I have solved this differently? How could I have come up to this optimal price using another method? So this could be, think of this as method 1. Well, method 2, which I've been using shamelessly, is I just cheat and I say P star is equal to 60 plus 13 divided by 2. Right? Which is equal to 73 divided by 2. Which is equal to 36.5. Exactly the same thing. This thing comes from that, right? But look how quickly I can get to that price, right? So I already know the answer, right? The moment I have the demand function, I already know the answer with this method. What if you wanted to use a third method? What would have been the third method? Yeah, Dorothea. Where I get the numbers from? Yeah, let me just kind of give you the general sense of this. The general formula for this method, and again, I don't want you to just, write it out, but if you have an A here, and if you have a marginal cost here, the optimal price would always sit at the midpoint between A and C. So the P star will always be A plus C over 2, or A plus MC over 2. So that's what I'm doing there. Okay? Yeah.
Is that only for a monopolist?
That is only for monopolists, and it must have constant marginal cost, and it must be a linear demand function. If it's not a linear demand function, you can't use that. If the marginal costs are increasing, you can't use that. But for MG431 purposes, we will always be dealing with linear demands and constant marginal costs. Okay? So your life is a little bit easier, but it's a good question to realize that this formula is not a general formula, right? If the demand function was not linear, you couldn't use it. The marginal cost was increasing with quantity, you couldn't use it. Okay. What's the third method that I could use to find that same thing, that same price? What's the third method that I can use to find the same thing? Yeah.
The
Yeah, the inverse elasticity pricing rule. Okay, the inverse elasticity pricing rule said P minus 13 over P must equal to 1 over the inverse of the slope. The inverse of the slope is just 1 times P over Q. So this will be Q over P, but instead of Q, I can write 60 minus P. Agree? So now I have one equation with one unknown. I just can solve that. Let's try and do that. Just to convince you that all three ways are, of course, equivalent, unless you made a mistake. So if you had a lot of time on the exam, you could do it in three different ways. You could check your answers in three different ways. So, so we have P minus 13 over P is equal to 60 minus P over P. The P and the P cancels out. P minus 13 is equal to 60 minus P. 2P is equal to 73. P is equal to 73 over 2, which is exactly 36.5. Three ways, same thing of getting to the right answer. If you look at that video that I did on inverse elasticity pricing rule, I give you the intuition why it works. The inverse elasticity pricing rule is focusing on the price. It's saying what is the right price. The marginal revenue, marginal cost rule is focusing on what's the right quantity. But because price and quantity are related to demand, they're the same thing. And of course, the second method is really just a cheat. It's really not a second method. It derives from the first method, right? And the third method is really not a third method. It's a rearrangement of the first method by focusing on price rather than focusing on quantity. I'm not going to do the second bit, but I'd like to see how you do on it. So if I give you 5 minutes on it, could you come up with what the optimal price is? Yeah. Yeah. Sure. I'll stop this here.